Lesson 8.3.10, Solutions. Solutions to linear equations. In this lesson, you'll understand what a solution is for an equation with two variables. And you'll also understand that the graph of an equation is a visual representation of all the solutions to that equation. You know what, before we get started with the notes about solutions, I want to review what you've done in previous years. You've solved equations before, but they just had one variable. And you know that the solution to an equation is any value that can be substituted in for that variable that'll make the equation true. Let me remind you of what we mean here. If we have this equation, y plus 6 equals 13, I can say the solution to that equation is y equals 7. Because if I take that value and substitute it in wherever I see y, it should make the equation true. Let's check it over here. Here's the same equation. And instead of writing y plus 6 equals 13, I'm going to write what I think my solution is. 7 plus 6 equals 13. That's what it means to substitute that value in for y. And if that's true, then 7 is in fact the solution. Since 7 plus 6 is 13, that equation works out. So that's why I can say that 7 is a solution, because I can substitute it in for the variable. We're going to be doing something really similar today, except our equations have two variables instead of one. So let's go ahead and get into these notes for Lesson 10. We're on page 140, and we really have two learning goals. The first is to understand what the solution to an equation with two variables is. Understand what the solution to an equation with two variables is. And also know that the graph of an equation of an equation is a visual representation of all the solutions to the equation. Well, let's talk about equations with two variables. Let me give you an example, and it's going to look a little different than the equations that we've been working with so far in this unit, but it still has two variables and it's still linear. So let's take the equation 4x plus 3y equals 24. And ask ourselves, what would a solution to that look like? Well, one example, there's actually an infinite number of solutions, but let me show you how I can tell that this is one example. The solutions are actually going to look like coordinates. One solution to this is the point 6, 0. Now, this equation has an x value and a y value, and you know that this coordinate has an x value and a y value. So just like we did with the equation in one variable, where we substituted values in for the variables and saw if it made the equation true, we're going to do the same thing with this equation that has two variables. I'm going to do some color coding to help us see what's going on. So for x, I'm going to substitute in 6. And for y, I'm going to substitute in 0. And we'll see if it makes this equation true. Let's try it out here. So I'm going to rewrite this equation, but instead of writing x, I'm going to write 6. So let me start with 4 times 6 not x, but 6, plus 3 times y, but instead of y, I'm going to write 0. And let's see if those two values, when I substitute them in, make the equation true. Just make sure we're clear that the 6 is what I'm substituting in for x, and the 0 is what I'm substituting in for y. All right, I'm going to follow the order of operations that says I need to do some multiplying first. 4 times 6 is 24, plus 3 times 0 is 0. And it looks like those two values made this equation true, because we know that 24 plus 0 is actually equal to 24. So that's what the solution is for an equation with two variables. Let's go back and define it up here. The solution to an equation with two variables is any pair of values like we had in this coordinate. We had a pair of values substituted in for the variables, to make the equation true. So one way we can check to see that that we have a solution is to substitute those things in. But there's another important thing to know. This equation, if I were to graph it, the solution to an equation with two variables is any point on the line that represents that equation. Let's see how I can say this. The solutions, and there's more than one, to an equation with two variables are points that are on the line representing the equation. I know it's a lot of writing today, I apologize. And I've actually graphed this equation, 4x plus 3y equals 24. This is what that graph looks like. And you can see that the point 6, 0 is actually on the line. In fact, any point that's on the line as a coordinate, that x value and that y value as a pair would make that equation true. I can prove it to you here. Hang on just a second. Let's take another coordinate. I'm going to take the coordinate 3, 4. It sits right there on the line. And if I were to substitute 3 for x and 4 for y into this equation, it would make the equation true. I've done it already here. I still have the equation 4x plus 3y equals 24, but I've substituted 3 in for x and 4 in for y. And when I did that, I got 12 plus 12 equals 24, which checks out again. So the point 3, 4, the x value 3, the y value 4, is another solution to this equation. How many solutions are there? Well, there's an infinite number of them. Any coordinate that sits on this graph, on this line, would work in that equation. So there's an infinite number of them. I just wanted to show you that graph because the notes didn't have it there. I'm going to bring that graph back one more time just to give you a non-example. Let's say I have that same equation, 4x plus 3y equals 24, and I want to know if an x value of 10 and a y value of 0 would make the equation true? Well, let's try it. I'm going to do some color coding again. I'm going to substitute in 10 for x and 0 for y. Let me just rewrite this equation, but I'm not going to write letters this time. I'm going to substitute in numbers. So 4 times x, and instead of x, I'm writing 10, plus 3 times y. Instead of y, I'm writing 0. Let's see if this works. I'm going to multiply first. 4 times 10 is 40. 3 times 0 is 0. Well, I shouldn't write an equal sign. That clearly doesn't work. Wah, wah, wah. So this is not a solution. It doesn't make the equation true. And going back to our graph, if I were, oops, let me scooch it over. If I were to look at the point 10, 0, point 10, 0 is right here. And clearly it's not on the line. So that's two ways I can tell if something is a solution. It makes the equation true and it sits on the line. Or it isn't a solution. It doesn't make the equation true and it doesn't sit on the line. All right. There's a few more facts that we want to say about solutions in two variables, but we just get to fill in the blanks. I know we've been doing a lot of writing. Let's scooch down a little here. Focus a bit. All right. A solution to a linear equation is a pair of values that makes the equation true. Second statement is actually the answer to one of the summary questions at the bottom. We'll come back to that in a minute. If I want to find a solution, solutions can be found by substituting a value instead of just a value, I'm going to say any value for one of the variables and solving the equation for the other. I want to show you what I mean because I think it comes up in your practice assignment. I'm going to go back to that same equation, 4x plus 3y equals 24. And you can just watch this. It says I can substitute a value for one of the variables. Well, okay, I'm going to choose anything I want and substitute it in for x. Let's see here. I want to choose 0. I think that's the easiest way to go. So I'm going to choose 4. I'm going to substitute in, I'm going to write 4, substitute in 0 for x, and then solve for the other variable that I've not touched yet, y. Let's see what happens. So 4 times 0 is 0. Equals 24. So if 3y equals 24, what times 3 is equal to 24? If I divide both sides by 3, I wind up with 8. Well, let's look at what we really did there. We chose a value for x. We chose 0. And out came a value for y. And that's a solution to this original equation. If I substituted those values back into the original equation, it would make that equation true. And the point 0.08 would show up on the equation represented in a graph. There's the point 0.08. It's on the line. All right, take a little side trip there. So solutions can be found by substituting any value in for one of the variables and solving the equation for the other. Another fact we can say is that the set of all the solutions to a linear equation can be shown in the coordinate plane, and it's called the graph of the equation. A graph is just all of the solutions. And the graph of a linear equation is a line. It's right there in the name. We saw earlier that any points in the coordinate plane that do not lie on the graph of the linear equation are not solutions to the equation. And finally, the number of solutions might be limited in a real-world situation, even though the equation itself has an infinite number of solutions. Going back to that same graph, if we're talking abstractly, you can see that this graph has arrows on either end to indicate that it goes on infinitely in either direction, which means it has an infinite number of points that are actually solutions to the equation. But if this graph really represented buying a certain number of cookies and cakes, it wouldn't make any sense to say we have negative cookies or negative cakes. So sometimes the solutions are limited even though the graph itself is infinite. So we'll just finish up with these two summary questions. I said earlier that the answer to this first question we already tackled. How can you find solutions to linear equations? Well, solutions can be found by substituting any value for one of the variables and solving for the other. Maybe we should revisit that example where I substituted in 0 for x. Oops. And then solved for y. I'll remind you that we chose 0 for x and we got 8 for y. And that's our solution. And finally, how do you know when you've found a solution? Well, there's two ways. If the coordinate appears on the graph of the equation, or I should say on the line, or substituting in the x and y values into the equation makes it true. So these are things that we should know about solutions to an equation with two variables.